best thing to do is show you this as well. One second. Right. So this is where everything happens. Google Classroom, all right, just to let you know, cannot use your school email. Your school email is protected. As in your school has your email protected, you must use your own personal email. So, NTA leave insert. Everything I've done over the last 9 weeks or 8 weeks before midterm is all up here. So every Monday, give or take Monday or Tuesday, the homework goes up in the class. Then the following week, the corrections will go up. And every video I've done, so everything I do in this class, just so you miss a week, you don't actually. The video comes up here. You literally click into the video, throw in your headphones at home, study, wherever you're allowed to do it. So, last day we don't. Yeah, unfortunately, you have to listen to me even when you're not here, alright? So, all the videos are up there. If you ever want to look back on a lesson, anything I've ever done, everything gets recorded on the app. Is that alright? So you miss nothing. You're fully free to go back and look at the last 9 weeks that I've done in algebra. So I've done algebra and I did functions and I did differentiation before. Alright? And the code for that, guys, actually is take this down on the front of your hardback. The code, Google Classroom, you can download it on your phone, you can download it on your, whatever you want to download it on. That's the code. Download it on a tablet, download it on a phone, you can download it on. That's the code to get you into it, and you cannot use your school email as it is protected. So you must use a personal email. And everything's in it. I'm sure you're used to it from using it in school now. Right, guys, let's jump straight into it then. So 2017 paper 1 question 3. Differentiate 1/3 x squared minus x plus 3 from first principles with respect to x. Right. Differentiate with respect to first principles comes up 2 in every 3 years. Very, very important. We know the formula. Adam, we know the formula, remember? What's the formula? Off you go. obviously you can check your answer clean, guys, if you just differentiate the quick way. You should be ending up with 2 over 3x minus 1. Don't worry, I'm going to do 2 of these, I'm going to do 1 of these and another one and 3. Right, it's like, guys, we want to do 2 of these, so let's have a look at this one. We'll jump on and do another one, alright? So, our formula is the function of function of x plus h minus the function of x all over h. So first of all, function of x plus h is equal to 1/3 times x plus h to be squared minus times x plus h plus 3. That's 1/3 times square the first, x squared, twice the first by the second, 2xh squared the last, h squared, minus x minus h plus 3. That's 1/3 x squared plus 2 over 3 xh plus 1/3 h squared, minus x minus h plus 3. So put it back into our formula then. 1/3 x squared plus 2 over 3 xh plus 1/3 h squared minus x minus h plus 3 minus, bracket the function of x, the original one, 1/3 x squared minus x plus 3. Right, let's start knocking things off. That's minus 1/3 x squared, knocks with 1/3 x squared. Minus by minus x is going to give us plus x. So that's going to knock with the minus x. Minus 3, because that's minus by plus 3, is going to knock with the plus 3. So you're left with 2 over 3 xh plus 1 over 3 h squared minus h. Then we introduce our h into the formula. The function of x plus h minus the function of x all over h. So that's 2 over 3xh plus 1/3 h squared minus h all over h. We all okay so far? That knocks with that. 2 over 3x plus 1 over 3 h. One of the h's cancels with the squared. H over minus h leaves you with minus 1. The last line, what's the last line in it? Because the h as the function of x plus h minus function of x over h as h approaches 0. Perfect. So the function of x plus h minus the function of x over h as h approaches 0. Do we know what approaches 0 means? Basically all the h's go to 0. So that leaves you with 2 over 3x plus 1 over 3 times 0 minus 1. They're gone. A final answer of 2 over 3x minus 1. This is a bread and butter 10 marks. Alright, didn't come up last year. Comes up 2 in every 3. Keep an eye out for it. Simple as that. The reason it's a bread and butter 10 marks is when you get down to here whether you're right or wrong, because you go straight back up to the beginning and you just differentiate normally. And then you know. Is that fair enough? Right, we're not going to jump onto this one yet. We're going to do one more of these just to make sure we're okay in it. So we're going to jump to We're going to do 2016 paper 1 question 6. Differentiate the function 2x plus 4 squared from first principles with respect to x. Function of x plus h. Let's say you want to check your answer, differentiate regularly. If you're differentiating that regularly, bring down the power, it'll be 2 times 2x plus 4, differentiate bracket times 2, so you should be left with 8x plus 16. Even before you start something, it's just in the top right corner, so it's handy to have an answer to work with, so you know if you're right or not. Right guys, let's have a little go at it. So, you can do this one of two ways. You can multiply it out at the beginning and then sub in your x plus h, or you can sub in your x plus h and then square it out. I'm gonna square it out and then put in my fx plus h. So, formula once again, function of x plus h minus the function of x all over h. So, first things first, square it out. Square the first, 4x squared. Twice the first by the second is 16x. Square the last, 16. Right, now the function of x plus h. Always with this, guys, out to the side of your little, obviously you'll be doing it on a much smaller scale than me. Put a little rough work sign out here so they can actually see your rough work, alright? The tidier you keep it in here, like I corrected leaving cert exams before, the tidier you keep it, the more marks I'm going to give you. I'm not going looking for work inside in the middle, buried inside the middle of a page. Do your little rough work out to the side, bring your figures back in, nice and tidy and neat, you're going to get yourself more marks. So, that's 4 times x plus h to be squared, plus 16 times x plus h, plus 16. So that's 4 times x squared plus 2xh plus h squared, plus 16x plus 16h plus 16. That is 4x squared plus 8xh plus 4h squared plus 16x plus 16h plus 16. So bring it back in then. The function of x plus h minus the function of x all over h. So that is 4x squared plus 8xh plus 4h squared plus 16x plus 16h plus 16 minus the function of x, which is 4x squared plus 16x plus 16. Right, let's start knocking things off. That cancels with that. Plus 16, that comes to minus 16x is going to cancel with that plus 16x. The minus by 16 is going to be minus 16 is going to cancel with, that should be a plus 16 there. It's going to cancel with that. Gone and gone. That leaves you with 8xh plus 4h squared plus 16h all over h. So that becomes then 8x plus 4h plus 16. The limit as h approaches 0. So that's 8x plus 4 times 0 plus 16. The final answer of 8x plus 16, because that knocks off. We all good? Right. So we're going to come back to the applications in a minute. That was a tough one that came up in 2018. We're going to do this, log. So, a bit of functions. Functions and differentiation go hand in hand, because what we do, we're differentiating functions. So there's a function bit in this, and then there's a differentiation bit. Anyone know what they want us to do here? The f of x is the ln of 3x squared plus 2. The g of x is x plus 5. Find the value of the derivative of, do you know what this means? I'm going to do the functions with before. Exactly, that means they want you to put g through f. Remember we did it before? The function and then circle g through x like that. They often use it in circles to different no horizon as well. So what they want you to do first of all is, anywhere you see an x inside the function of x, they want you to put in the value for g. The value for g is x plus 5. So this becomes the ln of x plus 5 squared plus 2, and then differentiate it. Alright? Off you go. Square it out first of all, and then differentiate it. How would we differentiate logs? Page 14, is it? My book, 2 seconds. So we differentiated before it. The rules for differentiation are on page 25. 25 in the logbook. For example, as u be ln of 4x plus 2, yeah? And I differentiate that the function dash of x. 1 over 4x plus 2 by 4. You got to differentiate your graph. Anyone who wants to look at the last 2 weeks differentiation, as the videos are up there, right? I've done all the logs, all the e's, all the basic differentiation we've done the 2 weeks before Easter, sorry, 2 weeks before Halloween. All the videos are up there. If you want to go back and have a go at any of the homework, any of the videos, just look them up. They're all up there. Anyone who has any problems, come straight up to me. If the videos aren't playing or anything like that, I'll sort it out. And the very end of that question then is, when you get the answer, at the point x is equal to a quarter. So don't forget to sub in x is equal to a quarter at the very end. Give your answer correct for 3 decimal places. So this was 15 marks. Differentiation first principles was 10 marks that year, this was 15. I'll give you one more minute, guys, just have a go at that. Right, so first things first, the function of the g of x is equal to the ln of 3 times x plus 5 to be squared plus 2, which is equal to the ln of 3 times x squared twice the first by the second, 10x, plus 25 plus 2, is equal to the ln of 3x squared plus 30x plus 3 times 25 is 75 plus 2, which is equal to the ln of 3x squared plus 30x plus 77. You happy with that? Right. Differentiate in ln. So that's the function of x, or the function of g of x. The function dash of g of x then is equal to 1 over 3x squared plus 30x plus 77 multiplied by the differentiate of your x. So the differentiation of that is differentiate 3x squared, we get 6x. Differentiate 30x, we get 30. And differentiate 77, and it goes to 0. Are we all okay there? That leaves you with 6x plus 30 over 3x squared plus 30x plus 77. 12 out of 15 marks. We're getting that far. Last 3 marks, x is equal to a quarter is 6 times a quarter plus 30 over 3 times a quarter to be squared plus 30 times a quarter plus 77. And literally fire it straight into your calculator. Zero 0.371, 3 SD 0.3719, so 0.372. There's your 15 marks. Anyone, any questions before we jump on? Right. Not going to do that one. We are, because it's local maximum minimum. Right. Bit of algebra, and then we're going to look into the applications of differentiation, the local max and local minimum. First things first, revision from algebra. The function f is such that the function of x is 2x cubed plus 5x squared minus 4x minus 3. Show that x minus 3 is a root and find the other two. Right, first bit is easy. Well, both it is. How are we going to show that x minus 3 is the roots? Original algebra. We solve it in and hope it equals 0. Regard. Anyone any idea how we're going to find out the roots? Long division, blah. We solve this into this, hope it's equal to 0. Find out the two roots. We say it's not x minus 3 divided into that, we say x plus 3, exactly. We bring the 3 over, so it becomes x plus 3, and we do long division into this. And we want to factorize in what we get on top, and that's how we work through roots. So we would have done this before on an equal. And the second part of it is differentiation, because we want to get the local max and local minimum. That's the most common question asked on applications, especially on question 8. Local maximum and local minimum comes up on paper 1, question 8, every year guaranteed. Yes, we've got our steps for long division, divide, multiply, change, bring down. So whatever left on the top, then we should differentiate. And differentiate or something like that. Y squared minus x minus 1, where do we get that? Try to differentiate that. That's what we're looking at, 2x squared minus x minus 1. Right, let's have a little look at it. So how do we check minus 3 as a root? We sub it in first of all. The function of x is equal to 2x cubed plus 5x squared minus 4x minus 3. So we're checking the function of minus 3 is equal to 2 times minus 3 to be cubed plus 5 times minus 3 to be squared minus 4 times minus 3 minus 3. Is 0 equal to 0? Good stuff. So it's a root. There's your 5 marks. Right, if x equals to minus 3 is a root, then we know if we divide x plus 3 into it, we're going to get our other two roots. So x into 2x cubed goes 2x squared. 2x squared by x, 2x cubed. So there's our division, now is our multiplication. 2x squared by 3, 6x squared. Change the sign of your bottom line. They knock each other out. Minus 1x squared. B, bring down. Minus 4x. After you go bring down, you go back up to long division. X into minus 1x squared goes minus 1x. Minus 1x by x. Minus 1x squared. Minus 1x by 3. Minus 3x. There's your multiplication. Multiplication into change. Change the sign of your bottom line. They knock each other out. Minus 1x. Bring down. Minus 3. Back up to the top again. X into minus 1x is minus 1. Multiplication. Minus 1 by x is minus 1x. Minus 1 by 3. Minus 3. Change. And you know you're right if you're left with 0. Take that out and factorize it. 2x squared minus 1x minus 1. Bracket, bracket, guide number, whatever way you want to do it. Whichever way you feel comfortable doing it. Minus 1 plus 1. 2x plus 1, x minus 1. And the final root we said was x plus 3. 10 marks. Right. The next part of this question then. Find the coordinates of the local maximum point and the local minimum point of the function. So this is differentiation. Whenever you see it, whenever you see local maximum, or you see maximum of a box or the maximum of a square, or anytime you start seeing maximum and minimum, we gotta start thinking differentiation. Alright? Whenever you see those words, minimum or maximum, we gotta start thinking differentiation. So, anyone, any idea how we get the local maximum and the local minimum point of the function? And what are we trying to say? Exactly. Differentiate your original function. Our original function was 2x squared plus 5x, 2x cubed plus 5x squared minus 4x minus 3. We differentiate this and we leave it equal to 0. Now, how you decide between which is the local maximum, which is the local minimum, some teachers teach you differently. Alright, so I'll let you do whatever you want first of all, and then I'll show you how I do. I don't need to differentiate the second time to prove which is which. Alright, so you differentiate 2x squared plus 5x, 2x cubed plus 5x squared minus 4x minus 3. You get two values for x. Is that okay? So you differentiate it and you solve it. So you'll be left with a quadratic equation when you solve it. You then get your x values and you sum back in here and get your y's. So you're going to get two x values and two y values. Is that alright? Right. Off you go. Have a go at it. Differentiate this, solve, get two x values, sum back in and get your two y values. And you can run into any trouble you can show when you're floating around. So there's your function. The local max and local min. no need to draw it, I'm just going to show you something. So you have a graphic in your head of what you're actually looking at. Yeah. So there's about 3 different ways you can actually get the local maximum minimum, depending on which teacher you have and teaching one of the 3 ways. Right, we all seem to be on fairly on the same line. 30 more seconds there, guys, and have a go at it. Right, so find the coordinates of the local maximum and local minimum point of the function. So we differentiate once. The function dash of x is equal to 6x squared plus 10x minus 4. Bring down the power, reduce the power by 1, and so on, and minus 3 gets knocked off, right? Divide across by 2 is what I take out a common 2 to make life a bit easier. Or, no, just leave it as it is. You can't take out a 2 there to make life easier. 6x and x. Plus 2 minus 2. 6x is equal to 2. X is equal to 2 over 6 or a third. You happy with that? And x is equal to minus 2. You can take out 2 to make life a bit easier there if your factorizing skills ain't great. So, what you do then is you sub these answers back into your original function to get your y's. So the function of x is equal to 2 times a third to be cubed plus 5 times a third to be squared minus 4 times a third minus 3. And that is equal to, anyone got an answer for that? What'd you get? Minus 100 over 27, or what's it as a decimal, guys? I'm going to leave it as a decimal for a reason, minus 3.7. So one of our points is a third, which is 0.33, and minus 3.7. Right. You didn't sub in your other one. Function of x is equal to 2 times minus 2 to be cubed plus 5 times minus 2 to be squared minus 4 times minus 2 minus 3. And that gives us what? 25. We all happy with that, guys? Minus 2 and 25. Right. There's 2 different ways of determining. We all happy with 25? You got 9? 9. Say the small mistake there, 9. So it's a calculator mistake, I wouldn't worry about that too much. You wouldn't lose too much marks, just a calculator mistake, alright? So, 3 different ways. Way number 1 is, right, well, first of all, anyway, it's a cubic equation. Anyone know what a cubic equation means? It has 3 roots. And in a cubic equation, if it's like this, it's going to be negative into positive. You plot your 2 points. You plot 0.33 and negative 3.7, so out to 0.33 down here to negative 3.5. That's a rough drawing. But that's what you do. You plot this point and you plot that point. That's probably the longest way to do it. Another way a teacher will tell you to do it is you differentiate for a second time and see is it less than 0 or greater than 0, yeah? Easiest way of doing this is which one of those points is higher? That's math. That's me. Easiest way of doing it. Which one of those y values is higher up? That one. That's going to be max. That's going to be easiest way to do it. We don't need to differentiate set. Okay, the only thing we really need to differentiate set time is when we do it later on point inflection. That's the only time I really differentiate set. Whichever one is higher, that's your max, and that's your min. You happy with that? Good stuff, right. We're firing through it, guys. More than halfway there. So just like next to them. That's your min. That's your max. Right, this one. Find the slope of tangent to the curve y is equal to x times the sine of 1 over x, where x is 4 over pi. So very similar to the one we just did. Not this, the last one, the one just before we just did. Anyone notice that about this? Right. First of all, anyway, those two words about slope and tangent. We see slope and tangent. Okay, won't much. Slope and tangent anyway. Differentiation. Do we know what we're actually doing when we're differentiating? Very important. So we don't know what we're doing. The question 8, question 9 are going to completely catch us up. When we start with an application, we want to do that in the last half an hour. Do we actually know what we're doing when we're differentiating? Finding the slope, exactly. So if you have 2x cubed plus 6x squared minus 5x plus 4. That's your function, yeah? See, it's random we have, for example, the function of x is equal to 3x plus 4. We just get rise over run. It's a straight line. That's a straight line. We get the rise over run for that, not a bottom, isn't it? The problem is that this, it's a curve. So when it's a straight line, you just get rise over run. Y equals mx plus c, you get the slope out. However, with this one, the problem is it's going to have multiple, millions and millions of different slopes because it's a curve like that. When we differentiate this, 6x squared plus 12x minus 5, we've differentiated that. That is the slope of that curve. Alright, that is the actual slope. It's not a figure, because the reason it's not a figure is it changes depending on whereabouts in the curve you are. And what this allows us to do is, on your x and y axis, there's your x and y axis. If you pick a certain point on the x-axis, that allows you to find a slope anywhere in that curve. So for example, I'm going to say that point right there is 4.5. At that point right there, if I sub in 4.5 of this, that's going to tell me the slope of the curve at that exact point. If I pick this point over here, minus 2.7 for example, if I sub in minus 2.7 into my differentiator, it's going to give me the slope at that exact point. That's what you're actually doing when you're differentiating. It allows you to find the slope of curve at any exact point. That's the whole point. Is that okay? Right. So we want to get the slope of tangent curve y is equal to that at that point. So the very first thing we have to do is differentiate it, and then we're going to find the slope at that exact point. Right. What type of differentiation is that? Product. Why is it product effect? Because multiplication. How do I know that? How do I know? How should I straight away boom? I know that's product rule. That's u by v. There's two x's. There's an x here, there's an x inside it. There's two variables. Whenever you start seeing two variables inside the function, product rule. Is that okay? Little hint for differentiating this. Change it to the x of the sine of x to the power minus 1. Makes it a lot easier, right? Bring the x up to x to the power minus 1. Great. Have a go at it. Rules for differentiating, page 25. Now this isn't a sine inverse or cos inverse, so don't make a mistake there. And as I always do in these questions, guys, come out to the right hand side of your copy. Rough work. There's your u is equal to what? The u dv is equal to V is equal to what? Sorry, du dx. Du dx. Keep your answers out to the right so the person correcting your example can see what you're actually doing. Pick up as many marks as possible. This is a tough one. Try tying it up as much as possible. This is a tough question, and one of the tougher ones I've seen now, bar the 2018 question. So at the point where x is equal to 4 over pi, have a go and see someone in 4 over pi. Right guys, let's have a little whack off this. As I said, this is tough. So, find the slope of the tangent of the curve y is equal to sine of 1 over x, where x is 4 over pi. So it's a u by v. So as I said, out the side, rough work. Your u is equal to x. Your v is equal to the sine of x to the power minus 1, right? You can leave it as 1 over x, but I'm just going to leave it x to the power minus 1. I think it's going to be easier because you can just use chain rule then to differentiate. Du dx is equal to, differentiate x, you get 1. dv dx, differentiate sine of x minus 1. So, when you're differentiating trig functions, and we did this the class before Halloween, once again, look back at the video, you can go through them all. You have to differentiate the trig bit, and then you have to differentiate the x bit. Alright, so there's two little bits of differentiation. Differentiate sine, and you get cos of x minus 1. You then have to differentiate your x minus 1. So bring down the power. Minus x to the power minus 2. Just so that looks a little bit nicer. The cos of x minus 1 by minus 1 over x to the squared. Right, so your product rule in is u dv dx plus v du dx. U is x by dv dx, which is the cos of x minus 1 by minus 1 over x to be squared, plus v, which is the sine of 1 over x by du dx, which is 1. Right, that would have got you half the marks already. So just being able to get that little differentiation, you've got over half the marks for that. You can still tidy up over here. Is that right? One of these x's is going to cancel with 1 down there. Is that alright? So that becomes minus 1 over x times the cos of x minus 1. Or you can say the cos of x minus 1 by minus 1 over x. Either way works there. Is that okay? Plus the sine of 1 over x. Right, now the fun bit again. When x is equal to 4 over pi. So we now have to do this. Once again, I'm going to come out to the side. The reason I'm going to come out to the side is we have an amount of 1 over x's. Is that alright? So what I'm going to say is, if x, another bit of rough work, if x is equal to 4 over pi, I want to get 1 over x and see what that is. Is that alright? So that's 1 over 1 divided by 4 over pi. 1 over x, which becomes pi over 4. How do we divide two fractions? Flip the second one and multiply. So 1 over 1 divided by 4 over pi, you flip the bottom one. Pi over 4 multiplied by 1 over 1, you get pi over 4. So that's minus pi over 4 multiplied by the cos of 4 over, what I'm going to do, I'm going to change that back to the cos of 1 over x to make it easier. So, see, do you want to make cos of x minus 1? That can also be 1 over x. So that's going to be pi over 4 plus the sine of pi over 4. Just so you're clear, guys, the cos of x to the power minus 1 is also equal to the exact same thing as saying 1 over x. Is that right? Just bring the x down to the bottom. And all you have to do literally is fire that straight into your calculator and you get out an answer. So that is minus bracket. What do we have to do to our calculator? Rad. Why rad? Because we're dealing with pi. Mod. Shift setup. You all know how to turn the calculator onto rad? On them sharp ones, I haven't a clue. They should all be burnt as far as I'm concerned, them sharp ones. minus 0.15. Correct the 2 decimal places, 0.15. Right, I'm just going to quickly run through that again, then we're going to move on to applications for the last 20 minutes. We're nearly there, but it's a good class. So, this picks you up so many marks. It's out to the right hand side, it's clean, it's tidy, and then you bring it back in. Don't try to do it all in one spot. Break it off for the examiner, make the examiner go right. I can see what he's trying to do out here, or what she's trying to do out here. Then bring your figures back in. It was u by v. My u was x. My v was the sine of 1 over x. I made it sine of x minus 1. It's easier to differentiate negative powers than fractions. Does that make sense? So, differentiate u, we got 1. Differentiate sine. When you're differentiating the sine, a trig function, you must differentiate the trig bit and then the variable. Differentiate sine, you get cos of x minus 1. Differentiate x minus 1. Bring down the power, minus x. Reduce the power by 1 minus 2. Tidy it up a bit, that's the cos of x minus 1. Minus your x to the power minus 2 comes down to the bottom line, and your negative power becomes a plus. When you bring a number up or down, the power changes, plus or minus, depending on what it is. I now bring what I have here back into my formula. U dv dx plus v du dx. U dv dx is x times the cos of x minus 1 by minus 1 over x to the square. Plus v sine of 1 over x du dx is 1. One of my squares cancels with my x's out the front. So it becomes minus 1 over x, because that's what's left, minus 1 over x, by the cos of x minus 1 plus the sine of 1 over x. That there would have got me more than half marks for that little section of the question. The last little bit though, as I said, the whole point of it is figuring out at certain points along your function, your trig function, where the place where they wanted us to figure it out was point 4 over pi is actually a point on an x and y axis. That's actually a point on an x and y axis, 4 over pi. I made life a bit easier. The reason I made life a bit easier is I had minus 1 over x, I had 1 over x, and I had 1 over x. So I came out with my little bit of rough work. X is equal to 4 over pi. 1 over x is equal to 1 over 1 divided by 4 over pi, which is pi over 4. And just sub back in by pi over 4 all the way across. As I said, one of the trickier questions you'll come across with differentiation, but manageable. It's not about getting it right, it's about picking up as many marks as possible. Alright? That's the most important thing. It's about picking up as many marks as possible. Right, let's move on to a few applications. Question 8 or question 9. I think it was question 9 this year in 2019. It's usually question 8, but I think question 8 was a patterns question. I think it was question 9 was something about, I can't actually think off the top of my head, but it was a differentiation question. They will train a differentiation question. They'll get you to sub in a value for x. They'll get you to find a local maximum, a local minimum. They'll get you to find a point of inflection where two of them are equal, and they'll get you to get the angle. All right? There's about 6 different questions, 4 of them come up every year. Unless they change things radically, which I don't think they'll do to you, it's going to come up something similar to this. Is that okay? Right. First things first. 2016 paper 1, question 8. The diagram below shows Sarah's first shot of the basket in a basketball game. The ball left her hands at A. We're nearly there, guys, 20 minutes, and into the basket at B. Using the coordinate plane with A at minus 0.5, 2.565, and B at 4.5 and 3.05, the equation of the path of the center of the ball is the function of x equal to negative 0.74x squared plus 1.193x plus that. Find the maximum height point reached by the center of the ball corrected 3 decimal places. What wants to do? Find out. What's jumping out there? What word? Maximum. Differentiate, leave it equal to, and stop. Off you go. Differentiate that, leave it equal to 0, and get a value. That'll tell you the maximum. You can always check off the graph anyone. You have a rough idea what it's going to be. So differentiate it and leave it equal to 0. And don't let me slow you down. If you want to jump on and do part I, fire away. So remember now, they want maximum height. You've got a value for x, you must get the y. Let's solve back in to get your y. I gotta jump to the jacks real quick. Right, let's have a look at the first bit. So, the function of x is equal to negative 0.274 x squared plus 1.193x plus 3.23. So we differentiate this. The function dash of x is bring down the power. 2 times negative 0.274. That's minus 0.548x plus differentiate that, you get 1.193, and that goes to 0, is equal to 0. Negative 0.548x equals negative 1.193. Divide both sides by negative 0.548, negative 0.548, knock them off, x is equal to 2.177. And if you think about it logically, if you come back up here and look at your diagram, that makes sense because the point's about there and 2.177 is about there. So we've got to sub it back in though to get our maximum height. So the function of 2.177 is equal to negative 0.274 times 2.1773 squared plus 1.193 times 2.177 plus 3.23. Anyone get me an answer? 4.529. Which, once again, if you look at it, makes sense. That's about 4.529 up there. Good stuff. Right. The next part of this question. Find the acute angles horizontal at which the ball enters the basket. Give your answer correct to the nearest degree. So find an acute angle to the horizontal which the ball enters the basket. There's B. What did I tell you was the whole point of differentiation? Getting the slope. So what do you think is the roundabout way they're asking you here? They want you to figure out what that angle is right there as ball enters. Is that alright? That's what they're asking. And we get the slope of this point. Now, if I give you, for example, function of x, 3 times 4, I told you, there's your straight line, yeah? And you get your slope, you get your rise over run, yeah? got your rise over run. So what's the slope of the trace for? 3. So it's 3 over 1. Yeah? How would you get the angle out there? That point. The tan of 3. That's exactly what we're doing. The only difference is they're moving it on from junior search straight line tan into curve tan. So we're going to get the slope of our curve and then get the tan. It's not tan, it's x equals to tan inverse of 3. That was a straight line, wasn't it? It's not a straight line, it's a curve. So we're going to get the tan inverse of the slope. And that is the acute angle which the ball enters the basket. Does that make sense? Okay, maybe. Right, have a go. See if anyone can give me an answer. What you get? 52 degrees. I have to look at it. I don't know fully off the heart until I'm sure. Give you one go, have the go a minute or two. As I said, it's not all getting the questions right, but having a whack off to get as many marks out of it as possible, especially with questions like this. You have to have a whack off and don't leave them blank. Oops. 7 or 8 minutes left. Let's get this question finished. Enjoy the rest of your weekend. Sorry, you can't see the question. Right, let's have a little go off. So, as I said already, they want us to find the angle at which that ball enters the basket. And at what point does the ball enter the basket? .5, isn't it? That's the point there at which the ball enters the basket. It enters the basket at 4.5. So they want us to figure out the angle of the slope at 4.5, if that makes sense. So we've already got the slope. We figured out the slope, negative 0.548x plus 1.193 is equal to 0. So that's the function dash of what's the point? Did I say what point does it enter the basket? 4.5, which is equal to negative 0.548 times 4.5 plus 1.193. So the slope of that then is negative times 5 plus 1.193 is equal to minus 1.273. So that is the slope at that point. The exact point of 4.5 as the ball hits the basket is the slope has a negative 1.273. So that means it's falling at a rate as it's running, negative 1.273. We want to get the angle of that slope. So we say the tan of x is equal to negative 1.273. X is equal to tan inverse of negative 1.273. And what do we get? 52. I'm getting negative 0.904. Oh, I have mine on red. Handy if I change it, buddy. Shift tan inverse of negative 1.273. Yeah, minus 52 degrees. Good stuff, Adam. No. Right, last question of the day, guys. Last bit of the question of the day. Oh, I'm not going to do that. That's trigonometry. Right, these two. Like the one we just did. This is a what? It's a u by b. U by b, right? Just like the cost, the x is the sine of 1 over x we did earlier on. This is just, the Examcraft 2017 paper 1 question 6. So the Examcraft 2017 paper 1 question 6. So that's pre-company. If you're a new budget, you're with DEB, so this is the other pre-company. Don't worry, we'll be returning to differentiation next year as we're on the run up to the leaving cert. Or not May or that, we'll be doing exam questions. All we'll be doing is exam paper questions. So we'll get the rest of these finished. Go off the second bit, guys. It's a inverse the bottom half of your log down there. The watch It is right. The inverse of your trig functions. It's an inverse trig function differentiation. But be careful, the x must be on top. Alright? The x must be on top when you're doing the inverse of a trig function. Trig inverse functions. One more minute just to get it done, guys. Right, let's have a little look. Finish for the day, be happy to know then. U by V. U is equal to x squared. Du dx is equal to 2x. V is equal to the sine of 3x plus 5. dv dx is equal to the cos of 3x plus 5 times 3. So u dv dx plus v du dx is x squared times 3 by the cos of 3x plus 5 plus v, which is a sine of 3x plus 5 by du dx, which is 2x. So that's 3x squared by the cos of 3x plus 5 plus 2x times the sine of 3x plus 5. We're happy there? Right, last bit of the question then, just to correct it. As I said, it won't work unless the x is on top. So whenever you're doing the inverse of a trig function, the x must be on top. So that then is, if y is equal to the cos inverse of 2 over x squared, another way of saying y is equal to the cos inverse of 2 by x to the power minus 2 over 1. Is that okay? So if we get dy dx then, the rule for dy dx for cos is minus 1 over the square root of a squared minus x squared. So your x is equal to 2 to the power of x minus 2, and your a is equal to 1. That means dy dx is equal to minus 1 over a, which is square root of 1 to be squared, minus 2x to the power minus 2 to be squared. Tidy it up a bit, which is equal to minus 1 over square root of 1 minus 4x to the power minus 2. By what? What? Not u over v. Remember what I told us? What did I say about differentiating trig functions? We must. Go on, Cleve, you're on the ball. Must differentiate the trig first and then the variable. We must differentiate the variable. You must differentiate the variable. You differentiate the trig first and then you differentiate the variable. Differentiate 2x to the power minus 2, you get minus 4x to the power of minus 3. Bring down your power. Minus 2 by 2x minus 4x, reduce your power by 1. Your final answer is minus 4x to the power minus 3 over the square root of 1 minus 4x to the power minus 2. Great class, guys. Good stuff.